All right. Good afternoon, everyone. Welcome to the first of our 3 days of CSEC webinars put on by the Regional Mathematics team. Our focus is on matrices. And for today's session, our focus is on addition and subtraction of matrices. Feel free to share the link with your classmates and your friends. Invite them to come on over so that they can participate in this exciting session. I will be your host today, Janice Simpson-Hales, and in the chat, I'll be supported by Dr. Isilda White. So let's get right into it. Our session focus for today. First, we're going to define the term matrix. All right, and so you should be able to define that in your own words. We're going to discuss the uses of matrices in our everyday life. We're going to state the order of given matrices. We're going to define and identify the elements of a matrix. We're going to define and give at least one example of each type of matrix. We're going to determine whether two matrices are compatible for addition or subtraction. And we're going to correctly add two or more given matrices. And then we're going to subtract a given matrix from another. Now, before we get into it, I'm going to ask you to type your name and your school in the chat so that we know which schools are represented. And again, remember, go out, share the link so that your classmates can join us. Now, to get into today's session, to get you warmed up, to see where we can go with this, look at today's brain teaser. Which of the following shapes, A to D, completes the puzzle? You can type your answers in the chat. So examine the shapes carefully and see which of the shapes from A to D best completes the puzzle. I'd love to hear your reason. All right, Dr. White, do we have any responses in the chat just yet?
No responses in the chat yet, Mr. Sales.
All right, get those fingers typing.
Still no response. Okay, I have Rihanna saying C and Gabby saying C and quite a few persons saying C.
All right, great. Could we ask one of the persons to just share their reason? That's interesting.
Jaden, I'm going to ask you to unmute and share. Jaden. All right, could we ask Gabby? Gabby's iPhone, could you unmute and share your response, your reason for your response? All right, I'm not hearing from Gabby or Jaden. Ranaya, would you like to share? I'm not hearing.
No one wants to share, Dr. White. That's all right. Let's see if they are correct. All right, so let's see if they're correct. And indeed, they are correct. It would have been lovely to hear their reason, but the pattern, each pattern accumulates as you go along. So the third pattern is a combination of the two patterns which precedes it. All right. So we're going to get right into it. We're going to start with a scenario and look at these two shops. We're going to find out what is happening in the background with these shops and see if that information can be useful for us as we explore the concepts related to matrices. So here we are. The tables below show the sales of TVs and radios over 3 days in shop A and shop B. Get your fingers ready. Get your microphones working because I'm going to be asking you a few questions and I'd love to hear your responses. All right. So here we are. Share 2 observations about the table. What can you say about these tables? All right. Let's see what is happening in the chat. Let's see if anybody can share their observations about the table. And I'm sure you should be able to open your microphones and speak as well as Dr. White facilitates you. All right. So 2 observations about the table. Anything yet in the chat, Doc?
There are no responses in the chat as yet.
All right, let's give them a few seconds to think.
Still no response in the chat.
All right. Well, if we look at the tables, we could see that there is a bit of information that has been condensed into the information that the table shares. Would someone like to tell me what the tables are saying? What information are you gathering from the table? When you look at the table, what jumps out at you? All right, so tables are used to condense information, to make it a little bit more readable and to provide us with information that is useful. Now, in this particular case, we can see that shop A is telling us about the sales of televisions and radios across 3 days. And those numbers indicate what is happening for each day for each shop. I see the chat is now lighting up, Doc. Can we take 2 observations from what they have to share?
Okay, Gabby is saying the sales of the items in 3 days period. And DJ is saying the increase in A for TV.
Okay, so you begin to interpret the information already. All right, who can tell me how many radios were sold from shop A on day 2? Can somebody tell me how many radios were sold on day 2 from shop A? Anybody, Doc?
Not yet.
How many radios were sold from shop A on day 2? Let me see if you're interpreting the table.
Okay, Ranaya says 8.
8, all right.
And
Anybody else?
DJ saying 8 as well. And I'm seeing 8 from a few persons, Jaden as well.
All right. How many televisions were sold from shop B on day 1? How many televisions were sold from shop B on day 1? Any response to that, Doc? 8
Okay,
is indeed
I'm seeing
correct for the
9
first question.
from Jaden says 9. Ranaya says 9. And
All right,
DJ
great.
is saying 9 as well.
Very good. 9 is indeed the correct answer, as well as 8 for the previous question. Very good. So it tells me that you are able to interpret the data. Very good. So moving on. The tables show the sales of television and radios over 3 days in shop A and B. How would you use this information to create another table that represents the sales of TVs and radios from shop A and shop B? What are you thinking? Tell me what you're thinking. How could you use this information? How could you use this information to create another table So we want another table. And what should happen with that other table? It should be able to give us a representation of the sales of televisions and radios from shop A and shop B for each day. I see the chat lighting up that. Somebody has something.
Right. Yes, DJ is saying the difference for the 3 days. Differences for the 3 days.
The differences for the 3 days?
Yeah,
right,
that's his response.
Total. DJ, we want the total. We want to know if I just want to condense this into one table that will show me the total for sales for television and radio for both shops. One table I need. What do you think that could look like?
All right, no responses yet.
All right. So I think they're thinking it through in a doc.
I think so too.
All right. So how would you complete the table below then to show the total sales for radio for shop A or shop B? Here I am. I've started the table for you. What information would I put for the total for day one for TV? What information would I put for the total for day one for televisions? What would I write there? What would give me that total? Think about it. I want to know the total for both shops on day one for television. What would I write?
Gabby says 14.
Ah, that's a nice number, Gabby. How did you get that number?
Gabby, would you like to share? All right, Jaden says add both numbers.
All right, which numbers would you add, Jaden? Tell us which numbers you would add.
All right, Jaden, would you like to share?
Seems to me that they're preferring the chat.
Jaden says add 5 plus 9.
All right, very good. I'm proud of you, Jaden. How about day two? Would someone else like to share for day two? What would I find the sum of to give me the total for day two?
All right, I think they're thinking it through. I know they're going to respond. All right, Gabby says 7 plus 8. Jaden says 8 plus 7.
All right, we're coming on, man. That's good. Very good. How about day three? Anyone for day three? Television?
Yes. Gabby says 4 plus 6.
Great. How about day one for radio?
All right. I think this response is for 6 plus 4 is the same one. That's from Jaden. Okay, Gabby says 3 plus 4.
All right, go Gabby. Very good. How about day two for radio?
DJ also says 3 plus 4. Gabby says 8 plus 5. I see Gabby's very fast on her fingers, man. That's
You're doing
Gabby.
well,
Keep
Gabby.
going.
Congratulations. And the final one, day three, radio.
Jaden says 5 plus 5. Gabby says 5 plus 3.
Ah, there you are. Quick fingers, Gabby. 5 plus 3.
And Diana says 5 plus 3.
All right, very good. So see, we would have condensed that information into a table so we can find the totals. So let's see when we wrap this up, what does it look like? So now this is our table and we would like to represent this in a matrix form. This might be a new word for you, but let's see what it means as we progress. All right. So here I'm setting up my matrix. All right. So I have my matrix for, what do you think these matrices that I'm adding, what do they represent? Because I have two sets of brackets that represent two matrices that represent something, and I'm going to go ahead and complete the total. So let's see, the first matrix. What information do you think the first matrix represent?
Mr. Days.
All right. You sure the days? Because we have 3 days.
Gabby
and
says
we have
TV.
TV. All right. Let's see.
Jaden says the number of sales for TV and radio.
All right. So let's start out with the first one. So for the first one, I have 5. And then I have 3. Remember, we're talking about shop A and shop B. So the first number that we are adding comes from which shop? So for example, when I say 5 plus 9 for day 1 TV, the 5 came from which shop? The sales from which shop? For TV would have been shop A, and 3 would have been the sales for radio from shop A.
All right,
so,
they are saying shop A.
All right, very good. And then for day 2, TV, I'm going to represent that on my matrix as well. So I have 7 from shop A for TV. What would I write for radio, day 2, shop A? Let's see what's happening.
All right.
Again.
Tejana says 8.
All right, very good. And day 3, what would I put for shop A? Day 3. For TV, it's going to be for TV for day 3 is?
Jaden says 4.
Very good. And for radio for shop A, day 3.
All right, Gabby says 4 and 5. Diana says 5.
Very good. Thank you. So we have the information for shop A in our matrix. Let's turn our attention to the information from shop B for our matrix, our second matrix. So let's run through this quickly. What would be the first row of numbers in my second matrix?
Okay, Gabby says 9 and 4.
Ah, very good, Gabby. How about my second row?
All right, I know they're typing. It's taking a while to come in.
Okay.
8 and 5.
8 and 5. And how about day 3?
All right, Diana says 6 and 3. Gabby 6 and 3. Tajana says 6 and 3.
All right, thank you.
I'm calling her name properly.
All right, so we would have already found our totals. And then at the end of this, we would like to know what the total is. So what is my total for sales for television from both shops? What's the final total? Television, day 1, both shops. What's my total?
21 coming in.
Say again.
Tajana and Jaden says 21.
You sure? TV total day 1 for both shops, it's 14. How about TV total day 2 for both shops? TV total day 2, both shops.
15.
All right, let me see, 15 correct. And I gave away a little one there. It was radio day 1, both shops. How about radio day 2, both shops? Radio day 2, both shops.
All right, Jaden is saying 21.
Radio day 2, both shops. What would I add to find the?
Jaden now says 13.
13. All right, let's go now. TV day 3, both shops.
All right, I'm seeing 10, 10, 10.
All right. And finally, radio day 3, both shops.
9, 8. One person says 9, one says 8, and a bunch of 8s coming in.
All right, excellent. So this is how we represent our information in our matrix form. All right, so we're going to see this form popping up a lot throughout our presentation, and take good note of what these matrix form looks like, because we're going to talk about that in a little bit more detail. All right, so let's look at the seating position for students in a class. We're looking at the seating position for students in a class. Now, let me ask you, let's discuss. Can you share with me Tim's seating position in the class? Do you see Tim? Type yes in the chat if you're looking at Tim.
All right, I'm seeing yes, yes, yes. Yes, all the way.
All right, great. So we're going to try to figure out what is Tim's seating position. All right. So let me give you a little start. I want to have it organized because they look organized in the class, don't it? And they look very happy as well. They're having a lot of fun. So we're going to say, all right, we know the students in the first row. So I don't want you to get confused. I want us all to regard which row we're referring to as row 1. And that is row 2. All right. Can you tell me which row Tim is sitting in?
All right, row 2 coming all the way, but DJ is a little ahead of us. DJ says row 2, column 4.
What? DJ, all right, let's see if you're correct as we progress. All right, DJ. All right, so we say, all right, Tim is indeed in row 2. I'm going to give you a little bit more information for some persons who may not be thinking like DJ. So I'm going to give you a little bit more information. So now I have included some additional information. Can you share with me which column is Tim sitting in?
All right, column 4.
Column 4, all right. Very good. So we could say then that Tim is seated in position row 2, column 4. All agreed? Type yes in the chat.
All right, the yeses are coming in.
All right, great. So now we could look at another way of representing this information. All right, so we're gonna say it this way. Tim is seated in position 2, 4. And when Tim is seated in position 2, 4, notice I didn't write the row anymore or the column. So what does that mean? The first number in this pair refers to which position? Is it the row or the column? Let me hear from you in the chat. The first number in the new form.
Jaden, Tajana saying row.
Right. And the second number in this pair refers to the
column.
All right. Very good. It is indeed the column. Now, when we look at a matrix, all the numbers, because matrix can consist of numbers and letters, all right? Now, each of these numbers and letters are referred to as elements, and each element has its specific position based on where it is located. All right, so let's look at this. We're saying the rows will run horizontally. And we can have any number of rows. And when we refer to any number of something and we can't count them and so on, what can we use to represent any amount? Let me see what they will come up with in the chat, Dr. White. Any amount of numbers. What could we use to represent it?
All right, let's see what they're saying. Not seeing anything as yet.
This is a common topic that children don't like, Dr. White, but it's very useful. Because when we don't know the exact amount of something or the number that represents it, there's something we can use that will indicate that number, whatever the number is. Anybody thinking of it?
I know they're thinking. It's going to come in a little while.
All right. And I'll go as far as to call it a particular topic. That sometimes when you're doing that topic, you're wondering if you're really doing maths.
All right. They seem to be thinking hard. I haven't seen any responses as yet.
All right. So what I'm really getting at is the concept of algebra. And in this case, we can say there are a certain number of rows, but we don't know exactly how many it is. So we can use a letter to represent it. All right. So we're using a variable. So we're saying we have m rows, a certain number of rows that can vary, but we're using m to represent that. And in addition to that, we know that our matrix consists of not only rows, but also columns. And we can have a certain number of columns as well. All right, so we're looking at a matrix consisting of rows and columns. And each element in the matrix has its own position based on the row in which it is and the column in which it is. All right, so in this case, we can say it's in a particular row, which we are referring to as M, depending on the row, and a particular column, which we're referring to as N in this matrix, because we're making it more general. All right, it's a general form. So this is what we refer to as an M by N matrix. And note, we refer to the rows first, followed by the columns. All right, so if we look at this particular element A, and we know that it is in row 1 and column 1, what do you think its position is in the new form of identifying location of elements in a matrix? We looked at the new form, we condensed it down to a new form, we interpreted that new form. What would be the position of this element? Let me see if somebody can tell me, Dr. White. We want the reduced form.
All right, Diana is ready. Diana says 1, 1.
Woo! Good job, Diana. Very good. Because the element A is in row 1 and column 1. So each element has its position. Excellent. So by way of definition, if we want to just nice up everything that we're saying, a matrix is a rectangular arrangement of numbers in rows and columns. And rows run horizontally, while columns run vertically. So that's very important. Very good. All right, so here I have a task for you. Get those little fingers ready because you're going to be typing up a storm. And if you want, you could also raise your hand so that Dr. White can acknowledge you and you can share verbally. All right, now let us see which element, listen carefully now, which element is to the immediate right of the element the element A11. We're going according to the rows. All right, let's see. So of course our form is IJ, where I refers to our rows and our I changes as we go down, and J refers to our columns, and J changes as we move to the right. So let us see which element is to the immediate right of A11. Let me hear what they have to say, Doc.
I know they are typing, but it's not there yet.
All right. So we want it has to be to the immediate right of A11, right beside A11, right in the middle there, so that we have the little line waiting for the answer. What element is going to go right beside
Diana
A11
is on the ball. Diana says 2, 1.
You're sure, Diana?
I'm sorry.
Beside A?
She said 2, 2. I'm sorry, I said 2, 1. It's 2, 2 she has there.
2, 2. You're sure, Diana? Look at it again. We want the element that's going to be right beside A11 to the right. We're going in the row. In the row.
Okay, Newland says 1, 2.
All right, let's see if he's correct.
Donna says 1, 2.
All right. All right, what's the next element in the same row now? This is so exciting.
All right, they are coming in. Newland says 1, 3.
1, 3. All right.
Zana 1, 3. Ellis 1, 3, and they're rolling in 1, 3.
Oh, wonderful. Now we're going down now. All right. We're going down now. We're going down the column. So which element will now be immediately below A11? Right below A11. Which element? Let's see.
Newland says 2-1, 2-1.
What?
2-1,
Wow.
2-1.
Congratulations.
That is lighting up. 2-1, 2-1.
Right. 2-1. Very good, because we are now in the second row, but the first column. Excellent. What about the immediate right of A21? Immediate right of A21.
All right. 2 coming up in the chat.
Very good. And right beside that, what's the next one?
And of course, 2-3 is in the chat. And they're all saying 2-3.
All right. And we're going to the next row now. What starts the next row?
All right. They're ready. 3-1 on the ball.
All right. Wonderful. So 3-1. Very good. And right beside that, 3-2. And the final one that we have made available here. What's that one? Who is going to tell me what that one is?
3-3 is there already. Diana was the first one to say 3-3.
All right, wonderful. Very good, students. So now you recognize that every element in the matrix has its own position. And based on that, we can make the connections and relationships evident among the different elements that we're going to be working with. All right. So let's look at this. What, therefore, are some information that you can take about adding matrices? What's your takeaway? Under what conditions can matrices be added? Because we looked at the addition of the matrices, we looked at the different elements in the matrix. So now, if you were to summarize it, what would you say would indicate to you that, yes, I can add these matrices? What are you thinking?
All right, I haven't seen anything yet, but I know they are thinking. I haven't seen any responses yet. All right, let's see who will be the first.
When can I add one matrix to another? When? Because we looked at adding the matrices, we're able to find the totals. Here we have an example of what it involved in adding matrices. Let's see if you can summarize, therefore, what happens when we add two matrices. Anything coming up yet, Doc?
Not yet, not yet.
I'm going to give them a hint. I'm going to give them the first one that I have.
All right.
The matrices must be, here's a big word, listen carefully. They must be compatible. That means they must have the same number of rows and columns. What does that also mean? That they must have the same order. Some new words coming in, but it basically refers to what we did before. Because in order for us to add the matrices that we have, we had to find the element that is in the same position for each of the matrix so that we could add them. So for example, 5 here is in position 1, 1, 9 is in position 1, 1, and I was able to add the 5 to the 9 because they're in the same position, and then they took on the same position in the answer. So the solution or the total for those two elements was in the same position in the total matrix. Let's try another one. Look at 7 and 8. 7 from the first matrix is in row 2, column 1, so it's in position 2, 1. The 8 from the second matrix is also in the position 2, 1. So when I add them together to get 8 plus 7, they're also, the response, the total is also in the same position, 2, 1. All right? So we're saying for matrices to be added, I must check to see that they are compatible. And what does compatibility mean? They should have the same number of rows as the number of, same number of rows and same number of columns. All right.
All right. Newland is saying equal. Example, a 2 by 2 can be added to a 2 by 2.
Wow, go. Yes, very good. Very good, Elon. And so the orders must be the same. So when we talk about order, we're talking about the number of rows that it has and the number of columns, and we multiply them. All right, we're going to look a little bit more on that a little later. Anything else that that must happen for you to be able to add one matrix to another? We say they must be compatible. There is at least one more thing that must happen.
Jaden Palmer said a matrix must be equal to add.
They must be equal in terms of order, all right? But here's the other one. Only corresponding elements are added. So I can't add an element in 1, 1 to an element in 2, 1. You see where I'm going? So you must make sure that you identify the corresponding elements that mean the same position in this matrix with the same position in that matrix. They're called corresponding elements. All right, good job. Quite a little mouthful there if this is your first time interfacing with the topic, but don't worry. We're going to get to some examples that will bring it home to you. All right. Now, we're going to look at these matrices and we're going to check to see if they are compatible for addition. Remember now, I gave you that word and I'm using up the words now, so you have to know what that word means. Remind me in the chat, what does it mean if I say I'm checking if they're compatible for addition? Trying to speak big words here. What do I mean? Type in the chat. What do I mean when I'm saying I'm checking if they're compatible for addition? What am I saying?
All right. AFC says to be in the same order.
Very good. Very good, AFC. I will change your name so I can big you up and big up your school as well. All right. So let's look at the first pair of matrices. We're going to start by first identifying the order of each, and then we decide whether or not we can add them. Is that all right? So let's go with the first one. So here's the first matrix, 14, 7, 15, 13, 10, 8. What is the order of that matrix? Remember, the order refers to the product of the number of rows and the number of columns. Can somebody tell me the order of that matrix?
All right, before I take that response, AFC intro to identify herself, and she says she's Amy from Aberdeen.
Woo! Go Aberdeen.
All right,
sure
now
Dr. White is happy about that.
Of course, of course.
All right.
All right, so let's go back now to the order. Miss Newland says 3 by 2 and 2 by 4.
Woo! Very good. So the first one is a 3 by 2 and the second one is a 2 by 4. Very good. Now tell me, can these two matrices be added? Let me know if you can add these two based on everything we discussed. I'm not telling you to add them, I just want to know if it's possible to add them. Yes or no?
Jaden says no. Dijon says no.
Why is that? Tell me why.
Newland says yes. So let's take a no and let's take a yes. Dijon,
yes.
Would you like to say why no? Dijon, I hope I'm calling your name correctly. Or Jaden Palmer, you said no. Would you like to explain? All right, I'm not hearing from them.
Yes.
Okay, Miss Newland.
All right.
Newland says yes. Would you like to explain, Miss Newland?
Why do you say yes?
All right, somebody's answering. Who is this? Is this Miss Newland?
Miss. Yes,
okay,
miss.
Go ahead. You said yes.
Mr. say it's compatible because because it what this was as addition, so it wouldn't be compatible. If it was multiplication, no, because it has the column, same amount of column and row, the two n values equal to, it will be compatible.
All right, thank you so much. But again, I'm happy you were able to self-correct to recognize that we're not talking about multiplication, we're talking about addition. So in the case of addition, we would have to say, no, they're not compatible. All right, let's look at another pair. All right, let's hear what you have to say about this pair. What's the order of the first one in this pair? Type in the chat. What's the order of the first matrix in this pair?
All right, 2 by 2, that's Amy saying 2 by 2. And
all
2
right,
by 2 all the way.
All right, and the second is also a 2 by 2. Can I add them? That's what I want to know.
Jaden Palmer says yes, it's compatible.
Very good. Thank you. And thank you for using up those terminologies as well. Very good. Let's look at our third pair. I know you're going to be sad when these finish, because they're so easy, not true? All right. Tell me, what is the order of the first matrix in this question? What are they saying in the chat, Dr. White? Question 3.
Miss Newland says 2 by 1 and Diana says 1 by 1.
1 by 1, Diana? Why 1 by 1? Remember, we're talking about the number of rows multiplied by the number of columns. In this case, 3 is in a row by itself and 5 is in a row by itself. So we could see that there are 2 rows, but 3 and 5 vertically forms just 1 column. So the order in this case is going to be a 2 by 1. All right, I hope that helps you. What about the second matrix?
All right, Anna DC says it's a 1 by 3.
A 1 by 3. So she's saying we have 1 row and 3 columns. Very good. So tell me now, students.
1 by 3.
All right, very good. Tell me, students, are these matrices compatible for addition? Are they compatible for addition? Yes or no?
All right, I see a no from Miss Newland.
All right, any more no's?
Diana is saying no.
All right, very good. And we're going to look at the final one now. So what is the order of the first matrix here? For question 4.
Newland 1 by 3, Diana 1 by 3, and 1 by 3 all the way. Everybody's saying a 1 by 3.
Very good. What about the second matrix now in this question? What's the order?
All right. They're saying 1 by 3.
All right. Is it overwhelmingly so?
Yes, overwhelmingly so. 1 by 3 all the way.
I love that, Dr. White. I love when everybody's saying the same thing.
Yes.
And especially when they are correct.
All
so I'm
the same
happy about that. All right. Congratulations. Very good, students. So you are now able to identify the order of a matrix, and you're also able to determine whether or not two matrices are compatible for addition. All right. A little later on, we're going to carry that out. All right, so 2 matrices are compatible for addition if their orders are the same. So that's just a quick little reminder to you. All right, so let's look at this. We're just summarizing everything now. So by the time we're finished with all the information on this slide, you could take a picture of this slide as your notes, as a summary of what we have done so far. All right, so get your fingers ready. Now, 2 matrices can be added if they are the same size. And the size of a matrix is also referred to as its order. And in this particular example, we know that the order here is a 3 by 2 because it has 3 rows and 2 columns. Remember, we always write the number of rows first. All right. In this particular case, for example, we see that we have 2 rows. The first row has the numbers 7, 4, 0, 1. And the second row has the numbers -1, -3, 2, 5. So we have 2 rows. And how many columns do we have here? Can I hear from the chat? How many columns is in this example? Get your ding dong fingers. Let's see the fingers
I'm
going.
seeing 4 all the way, all the way. Everybody's saying 4.
Very good. So we have 2 rows and 4 columns. So the order of this matrix is therefore going to be a, remember, we put the multiplication symbol in between. So we're saying it's a 2 by 4. Very good. Just giving you a second to take pictures. Now we're going to look at an example. And I want you to do this on your own and give me your answer. We're going to run through it together, but I want you to simplify these 2 matrices. And I need you to tell me the process that you go through to simplify them. All right, let's see. So I'll give you 1 second to do that. So the first thing we want to check is whether or not these 2 matrices are compatible for addition. Are they? Type yes or no in the chat.
All right, yes. Roger saying yes. Samsung, SN.
What are the orders? What's the order of the first matrix?
Roger 2 by 2, Jaden 2 by 2, and everybody saying 2 by 2. 2 by 2 all the way.
Great. All right, now, what are we going to add?
All right. Tajana says 2 plus 3. Dijon says 2 plus. As a matter of fact, Dijon has it all written out. 2 plus 6, 5 plus 3, 1 plus 2, 4 plus 1. And he has the responses.
Oh, wow. Excellent. Very good.
All right.
Very good.
Roger and Jaden saying 2 by 6. Oh,
All
I'm
right.
sorry, Dijon. I said him. She says, I'm a girl.
All right.
I'm sorry, Dijon.
All right. So very good. And that is, of course, exactly how we would have written out our response for that question.
Dijon.
All right. I'm trusting that everybody is okay with that. All right. So now we're going to look at another concept that I'm hoping you'll be able to figure out. So the tables below show the sales of TVs and radios over 3 days in shop A and shop B. Those are the tables. Listen carefully now. How many more TVs were sold each day from shop A and shop B? How do you think we could work that out? Type your thoughts in the chat.
Right, I know they're thinking. Nothing is there yet. Okay, Dejana says 5 minus 9.
All right, on the ball. So this actually takes us into matrix subtraction. Very good. So in this case, we would need to do a subtraction in order to be able to find the correct answer. So let's see what happens next. All right, so here are our days, and we're going to write this in matrix form. So we want to find out how many were sold. So this gives us, in this case, we're simplifying it in the table first. We're simplifying in our table first. So let me hear Dejan. What should I write for TV day 1? What should I write in this?
Dejana, would you like to open your mic and speak? Dejana? Dejana is not speaking.
-4?
Well, tell me what you're going to do to get the answer.
Miss 5 minus 9.
5 minus 9. All right, let's see. It says how many more TVs were sold from shop B than shop A? So remember, we're talking about TVs now. So in looking at what our responses can be, can our responses be negative? If we're talking about number of TVs, can I have a negative number of television in my house? So in this case, we want to see, because we know that shop B has more than shop A. So how would I find out how much more? What would I do?
All right, Dejana says 4. But Dejana, would you explain how you get the 4? Dejana, can you open your mic?
You subtract the smaller number from the bigger number.
Right. So tell me exactly which number you're subtracting from which in this case for day 1. 9 minus 5. Very good. All right. Anybody would like to tell me about day 2 for the television, the difference from shop B to shop A? What would I subtract in this case for day 2? Anything in the chat yet, Dr. White?
Not yet.
Day 2 television. How many more TVs were sold on day 2 from shop B than shop A?
All right, Diana is saying 8 minus 7.
Ah, very good, Diana. And what about same TV for day 3?
All right, Diana is saying 6 minus 4, and Tajana is saying 6 minus 4.
All right, very good. Now, let us transfer this into matrix form. Let's see if we can write this as a matrix now. So I've given you the first matrix that represents shop B. Can you tell me the matrix that represents shop A so that we can carry out the subtraction?
All right, nothing yet. All right, Diana is saying 5, 7, 4. And so it's Tajana.
What's
and
the order
Dejuni.
of that matrix that you're telling me? What's the order of the matrix you're telling me? How should I arrange the 5, 7, and 4? What's the order of the matrix I should arrange that in?
All right, nothing yet.
You gave me 5, 7, 4. How should I arrange it? What's the order of the matrix that I should put that in?
Okay, Dejana says 5 first.
Yes, but what? Give me the order first. Give me the order of the matrix that I'm to set up. Is it a 2 by 1, a 3 by 4? What's the order I should set up in order to put those numbers in?
Okay, Tajana says a 3 by 1.
Very good. A 3 by 1. So we're subtracting a 3 by 1. And our answer, because we're subtracting, our answer should also be a 3 by 1. All right, so let me know now, what's the first element in my response? And so I'm seeing here that I'm subtracting corresponding elements. So it's 9 subtract 5, that gives me 4. 8 subtract 7, that gives me 1. And 6 subtract 4, that gives me 2. All right, very good. So here's a question for you then. How would you describe compatibility for subtraction? Remember, we looked at compatibility for addition. How would you describe compatibility for subtraction? What would you say?
Nothing yet.
I know they're thinking.
Oh, yes.
So we're running a little bit over time, but we're not going to be too long. I'm going to wrap up within the next 15 minutes or so. All right, so stay with us. Thank you for joining us. All right, so we're looking at compatibility for subtraction.
Dejana says only when the bigger number is subtracted from the smaller number. And Anna DC says when the order of the matrices are the same.
All right, I like the second one. When the orders are the same, you can subtract. I'm a little bit not so sure what you mean about the bigger number and the smaller number, because we're referring to the elements themselves. All right, so in the case of addition, we identify that they have to be compatible, they have to have the same order, and we would subtract corresponding elements. Is that the same thing for subtraction, or is there some kind of difference? What did you know?
Okay, nothing yet. Nothing as yet.
No problem, Dr. White. But in the interest of time, we're going to push on while you think it through, all right? So 2 matrices are compatible for subtraction if their orders are the same. And likewise, in the case of addition, where we can add corresponding elements, in the case of subtraction, we subtract corresponding elements. And to go back to what was said earlier by the student, it doesn't matter which element is bigger than which, because we know that we can subtract, even if the numbers will be negative when we carry out the subtraction. But we will always take away the element in the second matrix from the element in the first matrix. All right, so if we have A minus B, I'm going to be subtracting the corresponding elements of matrix B from its corresponding element in matrix A. All right, I hope that clarifies it for you, sweetie. All right, continuing. So we're going to look at this one. It looks a little bit more complex, but let's work it through. I think one of the things that we generally have a little bit of challenge with in these types of questions is where we have to interface with integers, particularly negative numbers. And so we're going to take our little time, just a few more minutes, staying with me, to go through what would happen to simplify this particular question. Are you ready with me? Type yes in the chat if you're ready to go through this one. All right. Am I seeing anything, Doc?
Not yet.
All right. So if you're ready.
All right, they're coming in with their yeses.
All right, great. So now I need you to tell me again, because you see, this is something that is very important. Whenever we're going to carry out operations with matrices, we must check the orders, especially whenever we're carrying out specific operations. Because what happens in terms of compatibility, as you will see tomorrow, what happens with compatibility for addition and for subtraction may not obtain for multiplication. So tomorrow you need to be here. You need to invite your friends and everybody, tell them to come, because you're going to go through multiplication of matrices tomorrow. All right, so let's look at this now. What is the order of the first matrix? What's the order of the first matrix? Anybody typing in the chat, Doc?
Tajana says 3 by 2.
A 3 by 2. Is she correct? If you agree with her, type in the chat. Yes, 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 yes. If you agree with her that it's a 3 by 2.
Okay.
Any yeses in the chat?
The yeses are coming in. The yeses are coming in.
All right, great. What about the second matrix? You know we can't subtract unless the orders are the same. Check the order for the second one and let me know. Who is giving me that order, Doc?
Not as yet.
Not as yet. All right, the order for the second matrix. So we're coming down to this is our final question. Are we coming down? So we just need to know the order of the second matrix to see if we can proceed with the subtraction.
All right, Amy says 3 by 2.
3 by 2. All right, if you agree with Amy, type yes in the chat. Go ahead.
All right, the yeses are coming in.
Great. So remember now, we're going to subtract corresponding elements. So see, we have set up, and to help you, I color coded everything, especially for those who may have a little challenge matching corresponding elements. So this helps. So I've color coded the numbers for you so that should be easier for you to carry out the subtraction. So it's a 3 by 2. And so we have 2 3 by 2s and we're subtracting. So we expect that our response, our answer should have what order? What should the order of our answer be? If I'm subtracting a 3 by 2 from a 3 by 2, my answer should have what order?
Amy and Diana says 3 by 2.
Also a 3 by 2. Very good. All right. So let's see now. So what are we going to subtract for the element in position 1 1? Element in position 1 1. What am I subtracting?
All right. Anna DC says 9 6. 9 minus 6. Sorry. 9 minus 6.
9 minus 6. Can somebody tell me what is 9 minus 6?
3. Anna says 3.
All right. So just to help you, we're going to use the number line a little bit. So we have 9, positive 9, take positive 6. If we're using our number line, so we're going from 0 to 9. That's where we start. So we go to 9. And then we're changing direction. This negative sign here means we're changing direction. So I go all the way to 9, and then I'm coming back 6 spaces. So when I come back 6 spaces, where am I?
Sienna says 3.
3, very good. Very good. So that's our response for the first one. Write down your answers, so that when we give the final value set of elements for the answer, you can check to see if you're correct. All right, let's look at the next one. We're going down. So the next element that we're going to subtract is, of course, negative 3 take 2. When I have negative 3 take 2, what does that simplify to? Anybody?
Not yet. Not as yet. Okay, Amy says the signs are the same, but I think we need the answer, solution for that. So
Right,
give us
so
the
when I
solution.
simplify -3 minus 2, what do I get?
Sienna says -6. Are you sure, Sienna?
All right, let's go aside. We're going to look at another little method that can help her. All
All
right.
right.
So we're going to go
Amy says
aside.
add them and you get -5, says Diana. Diana, sorry.
So we're going to try the number line again just to see. So of course, that negative means we're going to change direction. So we're starting off, and the other one tells us that this is the direction that we're going to change. So we were originally going to positive, and then it says change your direction. So now we're going to change it from positive to negative. So let's see how that looks on the number line. So we're on our merry way. We're going from 0 to -3. All right. And then we have to change direction. We were originally supposed to go +2, but now I'm changing direction. So I have to go -2. That means I have to continue on my little merry way, 2 places. All right. So I'm going to be stopping at -5. So -3 take 2 will give me -5. All right. All right. So we have that one. So remember now you need to be writing down your answer. What element, what should I subtract in position 3, 1? Who wants to tell me that? What should I subtract in position 3, 1? Position 3, 1. What am I subtracting there? Anybody?
Diana is saying 5 minus 7.
All right. Very good, Diana. All right. And we're just going to step aside another little method. You can do your simplify your integers in different ways. Here's a new one. I'm not sure if you're familiar with that, but we're going to use the colored circle to represent -1, and we're using the open circle to represent +1. All right, so you're with me. So here, when I have a -1 together with a +1, what do I get? What does that simplify to? -1 plus 1. What does that simplify to? Anybody in the chat?
Not as yet.
If I have -1 and I add 1 to it, how much do I have? -1 plus 1.
Okay, Amy says -2.
-1 plus 1. All right, let me rewrite that another way. Suppose I have 1 minus 1. +1 minus 1. What do I have?
All right, iPhone says 0, but Diana says 1. And
all right,
so says 0.
0, because if I have 1 and somebody take away my 1, what do I have left? I don't have nothing left. So in both directions, -1 plus 1 gives me 0, or 1 take 1 gives me 0 as well. So whenever I have these two pairs coming together, a colored one and an open one, it gives me, I can cross that out because it represents 0. So let's see if we can try that to solve this problem that we have here. So I have 5 take 7. Now remember, the open circle represents my +1s. So if I want +5, how many of those should I draw? What are they saying in the chat? I want +5.
Nothing as yet.
+5. How many of the open circles should I draw? +5. How many of the open circles should I draw?
Nothing is there as yet. Okay,
Nothing.
Amy says 5, Diana says 5.
All right, good. I'm going to draw 5 of them. And now I want to take 7. So I have -7. How many of those closed circles am I going to draw?
All right, Sienna, Amy says 7.
All right.
Diana says 7.
Very good. And then I'm going to cancel where 0 is possible. All right. So look there, that one goes to 0. Any other? How many of them will go to 0? Let me see if you're following me. How many of those pairs can I cancel?
All right, Sienna, Amy says 5.
5
Diana
of those
says 5.
pairs. Very good. So what am I left with? What am I left with?
Sienna says +2.
Sure,
iPhone
it's
say
positive.
iPhone say -2. Diana say -2.
It's negative because I have 2 colored circles. And remember, a colored circle represents -1, and I have 4 of those. So my answer here is going to be -2. So that's another way to work with your integers if you don't want to use a number line. All right, so we have those. We're going to the next column now. So what's my element in row 2? Sorry, in row 1, in row 1, 2. Row 1, column 2. What element am I going to put there?
Diana says 2 minus 3.
Very good. 2 minus 3. And let's see, we can go aside to work this out because I know sometimes we have issues with our negatives and we know what this represents. And so we want 2 minus 3. Let's see how we would write that. How would I represent this? Tell me what you would write to represent this in terms of colored circles and open circles. Let me see who wants to try. How many would I start with colored or open? It really doesn't matter. So let's start with our open circles. How many of those would I draw? How many open circles would I draw?
Right. Diana says 2 colored. Diana says 3. iPhone says sure? 2 uncolored, then 3 colored.
2 uncolored, very good.
Then 3
then
colored.
3 coloreds, very good. And how many 0 pairs can I cancel? That's a fancy word we use for when it goes to 0. How many of those do I cancel? How many of those simplify to 0?
All right, iPhone says 2.
2, very good.
Diana
so I
says
cancel
2.
those 2. And what do I have left? What's my answer? What do I have left?
A -1 all the way.
-1, excellent. Sorry about that. What should be now the element in row 2, column 2? Row 2, column 2. What should I write there?
All right, let's start it before you even ask. 0 minus 4.
Very good. 0 minus 4. You know, we're going to go aside to just work this out a different way to help everybody who needs help with this. How could I therefore represent, I want 0 minus 4? Let me see who in this class is going to show me how to use my open circle and my colored circle to represent 0.
All right, iPhone is ready. iPhone says 0, no colored, and 4 colored.
You sure? Type it again. I need to represent 0 and I need to represent -4.
Well, Sienna is giving the response, the
yes.
answer. Sienna says -4.
Right? But how do I represent it with my circles?
Sienna, would you like to open 0? Your mic and speak?
How do Sienna, I represent 0 with my circles?
Sienna, would you like to open your mic and explain?
All right. Remember the 0 pair that we have there? So for my 0, I have an open circle and a colored circle. And what do I write for my -4? Who is telling me what I should have for my -4?
Nothing yet. All right, iPhone says 4 colored. Sienna says 4 closed circle.
All right, very good. And then how many 0 pairs can I cancel? How many cancellations can I do now?
Nothing as yet. iPhone says 4. Sienna says 0. Amy says...
Can I cancel anything here? What cancels?
Amy says none.
You sure? I don't have anything that can cancel here? No 0 pair? You don't see an open and a close that can cancel to 0? You sure?
I see no and none and nothing.
You sure? All right, let's see. We can cancel that one.
Amy says yes.
Yes, we can cancel that one. And then after we cancel, what do we have left? What do we have left now?
All right, -4 flood in the chat.
Excellent. Let me just go back 1 minute to finish that so you could see. Yes. -4. And let's go back to our question. And so row 3, column 2, what should be there? Row 3, column 2.
All right, Amy says 1 minus 3.
You sure, Amy? Look at it good. Look good, 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 good,
I
good, good.
won't say 1 minus 3.
Look good, 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 good. Look again. Look carefully.
All right, Amy says 1 minus -3 in bracket.
Excellent. Very good. And that's what we have. And we're just going to run aside for 2 seconds just to work this out. In this case, we're going to use the number line. And remember how we figure this out with our number line. All right. So we look at the change of direction. And this is where we were supposed to be heading in that -3. But because we change in the direction, we're going to go to positive. All right. So let's see. So I'm on my merry way going from 0 to 1. And then I have to change my direction from -3 to now be going into +3. So now I'm going 3 spaces ahead, full speed. Where am I now? Where am I now?
All
What
right,
are they saying in the
iPhone
chat?
says 4.
4.
Sienna 4.
Excellent. All right. So there we are. And so we have all of what we need to calculate. And let's see if this is what you had. That's what you got for your answer. You should have been writing them down, you know, so you know exactly how to complete your responses. Excellent. All right. So now we're just going to complete this. How then would you define a matrix? How would you define a matrix? Let's see if you can fill these words into this little passage that we have here. So in mathematics, a matrix is a rectangular. What would you write there? Which of those words best fit right there? In mathematics, a matrix is a rectangular what? Or table of what?
Amy says array.
Array, very good. So it's a rectangular array or a table of what? A table of what symbols or expressions? Which word do you think best
Numbers,
suits there?
Amy says numbers, iPhone say numbers.
Numbers, symbols, or expressions, very good. Arranged in what and what?
iPhone say rows and columns.
Rows and columns, excellent.
Sienna says
It's a pity I don't know who this iPhone person is.
And Amy says rows and columns.
Very good. Which is used to represent a what?
iPhone says mathematical object.
Mathematical object or a property of such an object. Excellent. You can take a picture of this. Again, this video should be posted on YouTube as well. So if you miss anything, you can go back. All right. So in mathematics, a matrix is a rectangular array or table of numbers, symbols, or expressions arranged in rows and columns, which is used to represent a mathematical object or a property of such object. Now, look at this. In everything that we do, you know, this little topic that replaces numbers with letters must show up, all right? Because we deal with a lot of variables in life. All right, so we're going to see, so it says table C. Let me hurry up and show you table C. So table C below shows the total sales for TVs and radios on days 2 and 3 at shop A and B. Use matrices to determine the values of A and B. Think it through. I'll give you 1 minute to jot down something and tell me what you're thinking. All right, let's go. Your minute starts now. All right, so we did start a little late, but thank you for sticking around. This is our last activity. Thank you for sticking around. Did you come up with anything?
Not as yet.
All right.
I'm not sure what iPhone is saying. iPhone say, I think so. iPhone, would you like to open your mic and speak? I'm not sure what you're saying.
All right. Just because of time, I'm going to press ahead a little bit. So work with me. So this is our table. We have shop A. There's a variable. That means we don't know how many radios were sold on day 3 for shop A. And we don't know how many TVs were sold on day 2 for shop B. Type yes if you think I'm correct. I know I should have asked you first how you interpret the information.
All right. Yes. Yes, coming up in the chat.
All right, great. So let's see then. We're going to see how we can use our knowledge of algebra to help us to solve this, all right? So let's see. So this is information that we have in a condensed form. So we know, this is what we know, this is what we don't know. Can somebody help me to write the matrix equation? Big word. Can somebody help me to write the matrix equation that will help me to solve this problem? We have done several matrix equations before, because I know you realize that when we're adding, it was a matrix equation. We had one matrix plus another matrix gave us the resulting matrix. And when we were subtracting, we had one matrix, and we subtract another matrix from that, and then we got a result matrix. And so that was also a matrix equation. So how could I set up a matrix equation for this information that would help me to determine the values of A and B? Any ideas?
All right, iPhone says 7,
Yes.
4 in one column,
7,
8,
4.
A in second column.
All right, of the matrix for shop A. All right. So we have.
Still iPhone saying B6 another column by itself.
Yes.
And still iPhone 5.3 another column.
All right. Do we know what this is equal to though? Do we know the total for these? Do we know the totals? When we add those two, what should we get? Any ideas? I know that I need to add these two matrix, one for shop A, one for shop B. And when I add them, I am given the total sales for the 2 days. So how can I use that information from both shops? All right, in the interest of time, you have something, Doc? Go ahead.
No, not yet. No, nothing yet.
All right, so we were given the totals matrix because we know what the total sales were. What is the total sales for TV for day 2? Let me see if you're following me. Total sales for day 2 television.
Tijana Amy says 12.
Good. Total sales for day 3 for TV. What's the total sales?
4 coming up. 4 coming up.
Right. What's the total sales for radio for day 2?
8 coming up.
What's the total sales for radio for day 3?
10 coming up.
Excellent. So we're going to fill that into our resulting matrix because we know what the total sales were. So let's see if we can set up an equation now to solve to find the value of B. What are you thinking? Because we know the idea of corresponding elements, we know we're adding, and we know what we're supposed to get. What would you set up as an equation to solve for B?
All right, iPhone is quick on this, and I don't know which is our finger. iPhone says 7 plus B equals 12.
Wow, isn't that amazing? So equation 1, 7 plus B equals 12. Excellent. What therefore is the value of B? Who can tell me that? What is the value of B?
All right, Diana, Sienna, Amy 5.
All right, and I suppose you would have done the subtraction there to determine the value of B. All right, can somebody give me the equation to find the value of A? The value of A. The value of
iPhone A plus 3 equals 10.
A plus 3 equals 10. Let's see if that's correct.
And the iPhone continue to work and say 10 minus 3 equals 7.
Very good. Excellent. So you see, algebra can show up in a number of different topics. It's not just in algebra alone, because here we're doing matrices, and we also can utilize our algebraic knowledge and concepts in this topic. Excellent. All right, so let me just go back in case you want to take a picture of this. Again, the video will be up on our YouTube channel, so you could go and view as well. But if you want to take a picture, go right ahead. And guess what? We have come to the closure of our session, and this is your homework. So tomorrow's session, we're going to continue. We're going to go into multiplication and some other concepts. So go right ahead, work out your homework so that tomorrow when you come, you can go through the responses with your facilitator. All right. So this is your homework. Please go ahead and take a picture of it, and don't go just yet. Want to thank you so much for joining us. But just to share with you that for tomorrow's session, our focus is on multiplication of matrices. And of course, we start at 4:30. Tell your friends, tell everybody, come out, because it's going to be an exciting time exploring concepts relating to matrices, all right? And then we follow up on February 1 with another exciting session as we wrap up the topic of matrices, all right? So thanks again for joining us, and see you again tomorrow.
And iPhone say, I learned a lot today.
Excellent. I'm so happy for that. Thank you so much for joining. Make sure you come tomorrow, and tell your friends, bring everybody, man. We can accommodate up to 300 persons on this platform. So please make sure you're coming out. All right. See you tomorrow.